All right, now we come to the interactive part of the afternoon. So we've got just under an hour, so I'm going to call it quits at about 4:25 to give everyone a chance to have tea, coffee and network together a little bit. But we've got just under an hour to ask these world experts in motor neuron disease any question you want to ask. So we're going to run it. We've got a couple of roving mics. So if you could please in the room put your hands up. If you're streaming live on Facebook, we have 2 operators sitting with computers to take your questions and feed them to me. We've already got some questions from the floor, and I've got a couple here that have already been submitted online.
First of all, thank you very much for a very informative and also very inspiring discussion from all of you, so thank you. A question about possible causes. I'm wondering if diet is one area that you've looked at, and I'm just thinking about maybe areas such as gluten and other allergic type areas that have caused issues in many, and maybe those haven't done the action or changed the food, they've continued on. Maybe has that been an area that's been a possible cause?
So diet is an important and increasingly researched area, but it's an area that's only just started to be researched properly, so we don't have all the answers. Diet is probably important because it affects your gut bacteria, and your gut bacteria seem to be important because the gut in everybody, after they've eaten, for example, becomes leaky, and the bacteria in the gut come into your blood, and then your immune system is activated and wipes them out. And that immune activation seems to be something that might be important in triggering inflammation, and if it's not calmed down, then that might be a process that is involved in ALS. Another reason diet is probably important is once you've got the condition, it seems that a high-calorie diet probably is beneficial. We don't know that definitely because we need to do a trial to look at that, and that's in progress. But people who lose weight more rapidly seem to have a more rapid disease course, and that weight loss isn't just because of muscle loss; it's actually a fat loss, and that's something that actually the pioneering work for that was is done by Derek and Shu. Derek's in the audience there, so he actually can probably answer this question better than anybody else in the room. So I don't know if you want to take it over, Derek.
Sorry, who's Derek?
So thank you, Amar, for putting me on the spot. Our studies are very small, and we're conducting them mostly through looking at patients in Brisbane. So it's very, very early, those studies are. And so most of the work that I can report and talk about is really the literature searches. And so there are instances where the diet can be important. A great example is if you're deficient in certain components within your diet itself, and I think vitamin D has been shown to be quite vitamin B, is very, very useful in slowing it, but only if you have a deficiency. So I think what I really want to say is just caution to the wind. Yes, there's evidence to suggest that a high-calorie diet can be beneficial, but of course we need to know who's going to be at risk for losing weight and whether or not that diet is actually going to encourage weight gain, which could also have a big impact on them, especially if they have a disability, and the weight gain itself is going to add added complications to that disability. So as was suggested by Amar, it's something that we really have to research a lot more in order to provide people with the right advice on what to eat and how much to eat, and also who should be eating what.
Matthew, Leonard?
Well, I think it's a very hot area, and you mentioned celiac disease, so there's a significant increase in autoimmune conditions in motor neuron disease families. That's the first thing. The second thing is the whole sort of landscape of the gut-brain axis is changing. We're seeing that particularly in Parkinson's disease. Probably some ingested material is part of the process that's taken up through the stomach, through the vagus nerve into the brain. And then another sort of stream of research that's very topical and will be covered a lot in the next few days is prion disease, prion proteins and the spread of prions through the brain. Now, it does look like there's a spreading mechanism. Obviously, this has never been proven for motor neuron disease, but I think Perth is a good territory because 20 years ago everyone thought peptic ulcer disease was due to acid production in the stomach. So when those conditions are discovered, it's a complete change. So I think you've got to have an open mind about the gut and its involvement in motor neuron disease.
Leonard?
Yeah, we asked patients to fill out questionnaires about their habit, diet on diets before disease onset. And we found that patients have a higher calorie diet, but have a lower body weight. So that could be some evidence for hypermetabolism in patients. That could also explain the weight loss. And we also see that patients that have more Mediterranean diet, so more vegetables, more fruit, that seems to be a little bit protective for ALS.
So we should all go and live in Italy.
Yeah,
Yep.
that's a good option, yeah. I like Perth too. But
Yeah. All right, we've got a question up in the back corner.
Yeah, I had a question around Leonard's presentation on clinical trials. And I think you proposed kind of the ideal moving forward clinical trial design or what's needed. But what I didn't see up there was really the creation and the use of biomarkers and how important that would be so that we can move away from ALS-FRS-R as a way to predict or gauge success of a trial. And there was no mention of even within a single patient, the rate of progression can change over the course of the disease. And I don't know that that's addressed at all in the current clinical trial design as you presented it.
yeah, the ALS-FRS score that we use now needs to be improved. I think we all agree. So we're working on that. We don't have results yet. We're all working on biomarkers, better biomarkers. They are going to be implemented in the future. The neurofilament, I think, is a new discovery that's now also, but it's a biomarker for neuronal loss, not for a specific pathogenic ongoing mechanism. That's so it is a good biomarker for neuronal loss that is going to be used, and it's also actually was also shown in the SOD1 trial that the neurofilament also would go down if the patient improved. So I think that's a very important new new biomarker that's probably going to be implemented in all new trials from now on. But I agree, we need better biomarkers, and we're all working on that. That will really shorten the trials, I agree.
I also think that there are now incorporations of rates of progression in clinical trials, although a lot of these have been done post hoc analysis. They're looking at the delta, the change of progression in patients, and some of the more recent medications that would include both masitinib and edaravone have moved forward by saying that they have a greater effect on the faster progressors. I mean, but this has been done as a post hoc analysis, so I think this has to be incorporated more at the beginning, the planning stages, as much as what you're saying.
The other issue, of course, is that motor neurone disease isn't a static thing, as you pointed out. It's something that changes. And having a biomarker that monitors that change actually maybe not what you need. You might need a marker that just tells you is the disease process active, and then how much can you switch it off, and that's not necessarily the same as a disease progression biomarker. So actually the biomarkers that we've got and that we're developing is a really challenging big area. And I think Martin Turner will be talking about that actually in the conference.
Got a question here in the middle of the room. Yeah.
Yes, I had a question for Dr. Al-Shalaby regarding the lifetime risk, the 1 in 300 by age 85. I presume those numbers were done with the European population. Had they been replicated in a non-European population? And if so, what would those numbers be?
So it depends what you mean by non-European population. They've been replicated in the USA, but of course that's a European-derived population, largely. I don't think they've been done in a non-European derived population, but they have been replicated in other places. A good way of checking the kind of, without doing the formal study, of just checking the rough level, which you could do in any country actually, is by looking at death certificates. If you assume that death certificates are relatively accurate, which they're not, but that gives you a rough rule of thumb of what it would be. So if you look in the UK, for example, about 1 in 300 death certificates has motor neurone disease on it. So it does match.
But it's a little bit lower in Latin American populations.
So obviously the average age of the population is going to affect it. If you've got a younger population, then it'll be a lower risk as a lifetime, because the life expectancy will be lower.
Any other comments on that one? We've got we'll take a question from Facebook live streaming. Thanks, Marek.
Right, this is a question from Dr. Sain from India, who unfortunately couldn't be with us as she was unable to get a visa for Australia. So her question is, what are your thoughts on copper?
Matthew, I might pass that. No. Yeah.
Yeah.
Well, look, I think for a start, it's good to see that there's interest in clinical trials coming from pharma companies, and CUATSM is an agent that has been supported through philanthropy from Australia. It actually started off as a ligand that's used for PET imaging of the brain, and so it was then patented through the Florey, and the first phase 1-2 studies have been undertaken in Australia. But I suppose the jury's out, and what people need to do now is do a proper phase 2 or phase 2-3 study, much as Leonard has suggested, placebo-controlled, because there can be a degree of sort of, everyone is positive, so patients are positive and clinicians are positive, and then when you get to the end of a trial and you see there's no effect, you wonder what that positivity was about. So I think you have to just do it properly through scientific channels.
We've got another question in the middle of the room over there.
So this question is more about clinical trial design in general. So the edaravone trials have shown the benefit of enriching for a specific population within the trial design, and that they go from showing no significant effect to a significant effect when they select for that trial, which I think highlights the importance of heterogeneity within a population. How feasible do you think this is going forward in clinical trial design, where you're trying to specify or enrich for a certain population where it might not be highly prevalent, and that you'd have to have a longer period of enrolling patients, which may make the trial design more difficult overall?
Yeah, I think. I think the design is a very nice design in the sense that it was designed based on a post-hoc analysis. So they first did a large study in 300 patients, no results, and then they did a post-hoc analysis and found that the subgroup may have an effect, and did a second study to confirm that. So that whole concept, I think, is very important. And I think that's one of the lessons that we should learn, that once we do a trial, we should keep the data close to us to actually to use the data for future developments of new treatment. In my personal view, and also, no, I shouldn't actually mention my personal view. I should mention the view of the EMA, so that's the European FDA. They think, or their opinion is that the duration of the trial, so 6 months, is too short to approve the drug in Europe. And we, as European centers, sent out a statement that we think the company should have done, or should do, a trial with a longer duration of at least 12 months to have some indication what it does on the long term, but also what it does on survival. So I think many companies are copying the design of the latest edaravone trial, and I think they forget that it is a post-hoc analysis, that it was a post-hoc analysis.
The other thing to know is, unless you know the mechanism of your drug of action and can pull out the subgroup of people who that might be important for, then doing a subgroup type of clinical trial isn't going to be a very easy thing to do. So we can see that with the SOD1 antisense trial that Leonard mentioned, where you can easily pull out from the mechanism of action that you know, which is to do with SOD1, and you know the people with SOD1 mutation are going to be your target. So you can do that, and you can look for a large effect even though you've got a smaller population, because your disease mechanism and the subgroup you pulled out match. The difficulty is if you don't know that information, which for most cases we won't, in which case the only way forward is the way Leonard has just said, which is you do a post-hoc analysis of a trial in everybody, pull out the subgroup that seems to have an effect, and then repeat the study in that subgroup of people. In fact, that's what we did do with the lithium study. So the lithium study that was shown, again by Leonard, where people with UNC13A genotype that normally gives you a bad progression, if you give those people lithium, it seems to improve progression. That's a post-hoc analysis, and so now it's being funded for a phase 3 study to confirm that effect.
So I'm just going to post a question that I'm always asked in my clinic, and I'm very interested in all of your replies on this. Why can't or doesn't stem cell therapy work? I want all of you to please comment.
Well, I think that is an important question. So that's one of the first questions that is asked. And I think that it's an emerging area of science, and it brings a lot to the table. The reality is that there aren't too many trials that have been taken through in appropriate centres under scientific guidelines that have shown a benefit. That's not to say that that won't happen. And so I said there was already one released today, and then there'll be others that are coming. And I think that this is an emerging area. I also think, though, that it's unlikely that you can rebuild an adult sort of neurology system, so the brain and the spinal cord. That doesn't mean, though, that you can't put cells in the environment that preserve the function of damaged or deteriorating motor neurons and other brain cells. So I think there's a number of different areas that people are looking at, and it'll be a massive focus of the meeting. So we'll probably learn more over the next few days.
So my view on that is that stem cells, the way most people want stem cells to work is that you'd put them into the nervous system and then they'll replace the lost motor neurons, that they'd grow and reconnect and rewire the nervous system. But that's almost impossible to achieve in practice because the nervous system is so highly connected and the nerve cells are so long with such a path. I'm going to try and do this Australian scale. If you had a nerve cell that was about 30 yards across, then the motor neuron axon, the actual wire bit of the nerve that connects to the muscle, would be like a tunnel going from Perth to Auckland. So it'd actually be a little bit further than that, about an hour's flight more than that. So maybe down to the South Island. So they're very, very long, and so it's a metre long typically, a motor neuron. You're asking the new stem cell to grow a wire into an existing nervous system 1 metre and find the target, which is very difficult to do, and at the same time be connected in all the other places. And it's a cell that doesn't know that body at all. Whereas when you're growing, you start off as a very small object and all your nerve cells are connected and then they grow with you. So the scaffolding is there and they know how to connect. So trying to regrow an adult nervous system is very difficult. So the only feasible way at the moment to use stem cells is to assume that they're going to secrete some kind of cocktail of substances that will keep the other motor neurons healthy around them. In which case they might work, but actually I would argue why not find out what that cocktail is and just give it directly.
I agree with Omar and Matthew. I just want to add that I think stem cell therapy doesn't have the antibiotics effect, so it doesn't stop the disease. Some clips on the internet suggest that people start running around. I know some of their physicians, and they say that the disease progresses afterwards, and people don't put that on the internet when it progresses. So I don't think it stops the disease. So placebo-controlled trials need to be done also for stem cell therapy. Some people say that it's unethical to use placebo in that kind of treatment because it's an invasive treatment. You need surgery, spinal cord surgery, so it's not ethical to use placebo. I completely do not agree with that because I think the more invasive the treatment is, the more important it is to do a good trial to show whether there's an effect, because otherwise people are going to be on surgery forever. So I think it's very important to very carefully measure the effect and also look at the burden of the treatment and the effect.
And I'll just add one more comment. The analogy along Amar's line in terms of regrowing motor neurons that I give my patients, it's like taking a computer and unscrewing it. You pull out half the wires, go to the local shop, buy another whole lot of wires, just throw it at the computer and screw it closed and hope that every wire connects to the exact right thing so your computer works again. We're just not at that level of technology to be able to connect this bit of the brain to this part of the body yet. We've got another question up the back. No? Okay, another Facebook question then. Please think of some questions. You've got a real opportunity here with world-class experts.
This is a question from Kelly. Could antiretrovirals be useful for all ALS patients or only a subset that are HERV-K positive?
Can we answer that? Yeah. So in the initial study that I showed you, where 60% of people have a retrovirus signal in their blood, That doesn't mean that only 60% of people will ever have a retrovirus signal in their blood. We've done some other studies more recently that suggest that actually the retrovirus signal comes and goes in everybody. And so just if you do a cross-section of people, then about 60% at any one time will have it. So it's likely that if antiretrovirals are effective, and that's a big if, we've still got to do the trial, but if they are, then they're likely to be of benefit in most people. There's no reason to think they'd only work in people who have that retrovirus signal. It may be that eventually we can pull out a subgroup that does, but at the moment there's no reason to think that.
Any other comments? I think I saw the... Is there a question over there? Right over to the side.
Hi there. Has there been any proof that medicinal cannabis helps the neurological system with this disease?
Yeah, well, I mean, a lot of patients are on medicinal and non-medicinal cannabinoid therapies, and it is very effective in managing a lot of the symptoms of motor neurone disease. No one has done a trial to look at effects on disease progression, but I suppose it's a really emerging territory, and the typical sort of cannabis approaches that we may think about, that's only one part. There's about 9 variants, and I think this is, again, a science that's developing and evolving. But at the moment, I think all you could say is very useful for certain symptoms, no clear science suggesting effects on disease progression.
Anything to add? We've got a question here again in the middle of the room.
Okay, so this is for any of the three in the front. So normally we have very animated discussions during research visit with patients, but the other day the conversation died very quickly. It was a patient with a family history, and they asked us whether or not they should select against MND when they go for IVF. Do you have any opinions on that?
That's an option. It's a choice. I mean, I think, yeah, it is possible. So that's an advantage of genetic testing, that actually you can select an embryo that doesn't have the mutation. So that could be a reason to do genetic testing.
So I would ask which variant they carry.
Yeah,
If it's a variant that doesn't have a high penetrance, in other words, it doesn't necessarily mean you're going to get the disease, that might be a more difficult question. But if it's, for example, the A5V variant of SOD1, we know if you carry that variant, you're very likely to develop a very aggressive form of ALS. Then that probably would be a reason to consider an IVF approach where you're selecting not to have that variant.
It needs genetic counseling, of course.
Yeah.
Carefully do.
Yep. I mean, so we actively do that pre-implantation genetic diagnoses, and I would say, you know, the families and the individuals are very happy. It's not really up for us to make the decision, but if they want to do it, of course we're going to support it. And taking a step back, if you could have that power that you wouldn't have to go down the pathway and have that hanging over you, I would say it gives people a lot of peace of mind.
Yeah. And it's important to say you can actually do it without the person, so anybody can have this done without even knowing their own genetic status. So if you have a family history, but you know the gene in your family, but you don't yet have symptoms, and you don't know if you're carrying a disease gene, you can still have the fetus tested, the embryo tested and selected without knowing your own genetic status.
Once gene therapy is coming, that whole
Yeah.
kind of debate will change substantially, because then it becomes a treatable disease. It's most likely that there is an option also maybe for prevention of carriers. So it may become more important to know how your genetic profile is in the future. These kind of questions will come.
I'd be interested, Merrily, what do you do?
I also give my patients the option, and I explain to them what the options are these days with pre-implantation diagnosis and whether they themselves want to even find out with predictive testing, and then I send them to genetic services for the genetic counselling for them to make an informed choice. Yep. I have a sort of related question that came online, so it's again related to gene therapies. This says, of all the potential therapeutic approaches and technologies right now in 2019, antisense gene therapy appears to be emerging as a front runner and seems to have legs to complete the journey. Should we seek to accelerate research and investment into this area as a matter of priority globally? And if so, what are the urgent prerequisites for doing this as expediently as possible? Thoughts?
Do you want to start?
Yeah, I think for the SOD1 now, it's a reality now that patients, there's a shortage of patients.
Mm.
So we need better databases and more patients. So we need to involve Asia as well and other continents that are maybe less involved now to actually have sufficient number of symptomatic gene carriers to do these kind of studies. I think that now, whether the same effect will be found in the C9orf needs to be, of course, investigated. But the hope is there.
Well, I suppose it has been prioritised in the fact that, like this week, a number of companies are coming here to try and organise their various approaches. So I suppose that just shows from a business model approach from industry, pharma, they think it's worthwhile, and that they're the ones who can drive this process. So I think we'll see a lot of developments.
And it's important even for people who don't have a family history, because up to about 14% of people in the UK, for example, and probably in other parts of the world, have a gene variation that has a big gene variation that would otherwise cause familial motor neuron disease, even though they have no family history. So actually gene therapy might be important for a very large number of people. Maybe 1 in 6 people could be treated.
I think it's such an exciting field, seeing human trials now being done in the SOD1 patients and C9orf just on the horizon. And if you look at other neuromuscular disorders, a related one, spinal muscular atrophy, you know, there's a gene therapy there that's a potential cure. So I think there's genuine hope. I agree.
We've actually we've just given our first C9orf72 injection.
Oh, fantastic. Oh, that's exciting.
So what's the policy in Australia on genetic testing? Also, do you give the option to all patients, also sporadics?
So it varies from centre to centre, so we'll hear what Merrily does. Because I think, well, C9 is, in our Australian population, present in about 6.5% of sporadic ALS, we test, or we offer the test to all patients.
Yeah, so do we.
I too discuss it with all patients because of the sporadic numbers that are positive actually for genes even without a family history, and then I let the families make decisions because of the implications on insurance and on family members. Some patients decide not to test and others are very keen to test, so I leave it up to them.
Just it reminds me though of your 4 footballers. Were they related?
Not as far as we know, but they were never tested like that.
Right.
We had a question I think down the front here. Sorry, who's got the microphone? I can't see. Morag, okay. More Facebook questions.
Yep. Oh, another Facebook question. So this is from Anne. Is it still useful for someone who has been living with MND for 12 and a half years to continue to take Riluzole?
That's for you, Mark.
So I don't think anyone will really know the answer to that. The evidence, if you look at all of the databases and do the analyses, which Leonard and I have done, and I think Matthew has done as well, shows that Riluzole seems to have its biggest effect at the start of the disease and at the end of the disease, but probably does have an effect actually in the middle part as well, but to a smaller extent. So in those studies, we didn't make any assumptions about the duration of the disease. It was done by clinical staging, which we haven't discussed today, but it's something that happens in cancer where you stage the disease and you say stage 1 is early disease all the way up to stage 4 or 5 is late stage disease. You can stage motor neuron disease the same way, and you can show that Riluzole has an effect in stage 1 and stage 4 that's biggest, but does also have an effect in stage 2 and 3 that's smaller. So it doesn't matter necessarily that they've had the disease for 12 years based on that kind of evidence, because we didn't take into account disease duration. So nobody really knows, but my guess would be probably it is still worth it. The other thing to say is that the original clinical trial of Riluzole showed a 38% improvement in survival at 1 year. That's why people say it gives you 3 or 4 months improvement. It's actually not 3 or 4 months improvement really, it's 38% at 1 year because that's all you can say. But the method used, the statistical method used, is what's called a proportional hazards method. And that assumes that the effect continues regardless of how long you take it. So that would suggest if you've had the disease for 10 years, and you've taken Riluzole all that time, you'd get a 38% improvement in survival on average over that 10-year period, which is another 3 and a bit years. So you could argue that if you've got slower progressive disease, it's better to take Riluzole.
In my experience, it's safe. The long-term safety is not an issue. I mean, I've had many patients that have used Riluzole for years without any problems. So personally, I would say if you don't experience any side effects, I would just continue using it.
If it ain't broke, don't fix it. Yep.
Yeah.
Have you got any other? Oh, we've got one down the back, sorry. There's a hand up. Yep.
Thank you. Kathy from the U.S. Could you speak to delay to diagnosis? When we looked at the slide on the poor uptake on clinical trials, I know in the U.S., by the time many people are even diagnosed, they're out of the window for eligibility to a trial. So,
Yeah, the prediction model that we developed could solve that partially. So that is not a fixed disease duration, but it depends on those 8 variables in prediction model, whether you will be included in the trial. So that may help to enlarge the number of patients that are eligible for trials that can be included.
The other problem for clinical trial eligibility is many trials require you to be able to swallow for the duration of the study. And that's because if you change the formulation so that it's a form that can go from a tablet into something that's then crushed in the trial, technically that's a different formulation and therefore wouldn't be part of the same trial. So the only way around that would be if companies made things that don't depend on you being able to swallow easily, such as a liquid. Even then, administering it through a PEG tube, for example, you'd have to know that it doesn't stick to the plastic of the tube. So, but it's not an insurmountable problem, and I think that's something they should also concentrate on, because otherwise that excludes automatically about 25% of our patients.
And I suppose with the advent of more clinical trials, it's inevitable that the diagnostic delay is going to go down. There's going to be far more, I mean, I wouldn't call it a positive diagnosis, but clinicians will be more likely to make the diagnosis. I mean, in the environment, say 40, 50 years ago, where there's nothing that people could offer, there was perhaps a nihilism and a suggestion of why come up with a diagnosis. And I think that whole environment is changing very actively, driven by patients, families, and also by having dedicated clinicians working in the field. But the diagnostic delays are going down.
It is a very difficult journey, I think, for patients. I think Drew alluded to it earlier. They were the most difficult months. And if you want to tick all the boxes for some of the diagnostic criteria, you can wait many months or even sometimes years to tick all those boxes before perhaps some clinicians are, perhaps sure enough to say that it's definitely motor neuron. But I think, as Matthew said, there's a reason to diagnose people earlier, even if it's in one limb these days. I think people are more often receiving that positive diagnosis or getting referred to the right people who will make that diagnosis more confidently.
Also, I think there are criteria for enrolment in clinical trials, and that's different from diagnosis. So you might be forced to go down to certain criteria in a clinical trial environment by the sponsor. And I suppose taking that also further ahead, there's a meeting tomorrow of the World Federation of Neurology, and there was a meeting earlier on in the year about coming up with diagnostic consensus guidelines that would actually try and streamline the engagement of patients in trials earlier. So that's something that I think everyone realises that needs to be improved.
All right. Feel free to keep putting your hands up so the microphone people know where to go for questions. Oh, great. Yep, up the back here.
Hi, can you comment on the reliability of the NCALS predictive tool and what, if any, are the barriers for it being used more widely in a clinical setting?
So it's quite reliable for patients that have a average disease duration or a short disease duration. If the prognosis is better, the interval, the confidence interval becomes wider. So then the prognosis is, it's more difficult to predict an 8 or a 15-year-old survival than a 3 to a 5-year-old survival. So that's part of your answer. It is available through the internet to caregivers and not to patients yet. And because we talk to ethicists whether it's actually ethical to, because it could be a disappointment if it's shorter than expected. So we did not make it available for patients yet. We are investigating that now in a proper way. We actually doing research on that, how people react and whether they regret that they have done the test. So we're a little bit careful to make it available to the public yet.
I would also say it's not giving you a single number. It doesn't say
No.
you will survive this long. It gives a probability curve for the likelihood of survival to a certain length of time.
Yeah.
And so there's always a probability that you'll live a long time or a probability you'll live a short time, regardless of what the actual middle part of the prediction is. And I think it's important to bear that in mind, and most people can't really understand probabilities very well. A way of thinking about it, which I always tell my patients, is that I can make a very accurate model that will predict the survival of the light bulbs in this room. And I could come back in 5 years' time and count how many light bulbs are still there, and I'd be correct because my model's nice and accurate. But I wouldn't be able to tell you if that particular light bulb will be there in 5 years. And it's the same kind of problem that a survival model does. It's useful for selecting people for trials, because on average it'll work. But for an individual, it's not necessarily so useful.
It's a really important point. Are there any other Facebook questions? Yep, let's go to Facebook.
All right, so it's a question from Carly. What clinical trials are currently underway in Australia?
Well, the genetic therapies are underway, so the SOD1 study nationally, and then C9 will kick off in the first quarter of next year. I'm pretty sure the CUATSM is recruiting at present, and there's the refals and cytokinetics recently finished. And there's also going to be a nano gold study that will kick off perhaps before the end of this year. They're the ones I know of. Do you know?
Triumic,
So the Julian Gold study should be kicking off through the European and Australian partnership, depending on what Leonard thinks these
European
days.
Partnership.
But that should Leonard's convening a meeting this week, and we'll hear more about that. Just back to his other stuff, I mean, the NCALS model, I think, is a very important piece of work, and I think something that Leonard has driven himself with his group and now through NCALS, and I think it'll be a very powerful tool and will help streamline the clinical trial approaches, and I think that's an example of the innovative approaches that people can come up with using the technology of the day. The other thing with biomarkers that we're struggling with is we don't have too many positive clinical trial agents. But we'll have, like, the first session on Wednesday is Martin Turner giving an overview of biomarkers, and there'll be whole sessions on biomarkers. What we really need is 1 or 2 therapies to come through to refine the biomarkers to a greater extent.
Yep. There's a question down the front here.
In that sense, it's an exciting time that many companies are interested in ALS. So it is, I think it's somewhere on the list that it could be a treatable disease in the future. So I think that in that sense, we're all very excited.
I was really interested in the discussion about personality as being a possible cause, and when you think about people like Drew and my father-in-law and many others that all of us have come into connection with, it tends to get the best of individuals. And I'm just wondering whether it should be the role of parents to bring up our kids differently. We should be treating them as, like, they should be nasty, they should be physically inactive and medically unfit and so on. I mean, it'd be interesting to explore that a little bit more, wouldn't it, the personality side?
We should do a randomised trial.
Observational might be more ethical.
In our study, we found that patients with ALS are actually otherwise healthier than the control group and fitter. So in that sense, it's difficult. You become in the area whether you want to have cardiovascular disease or ALS. I mean, that's a stupid discussion. Yeah. Yeah.
And I suppose everyone in this room is a sort of product of tens of thousands of years of evolution. So everyone here is a success story. And then you say, well, why would motor neurone disease exist? And I presume there were certain evolutionary benefits that people saw from this. And people talk about, running till you drop. So having that sort of athletic approach, that was something that probably you know, when people were dying at the age of 35 or 40 standard, that you'd want these people, these key sort of individuals as part of your group. And I suppose the C9orf gene has come from in the majority from a single sort of Finnish person of mutation about 1,000 years ago. And then we can see that sort of spread through Northern Europe, through Viking spread into North America, down to Australia. It didn't really go into Asia very much because they had the Taipan dynasty and they had their own great warriors and they got rid of the Europeans. But you can see that that this is what society wanted. And now we're seeing the flip side of that as people are aging, getting into, 50, 60, 70, 80 more often, that we're now seeing neurodegeneration playing out more commonly.
There's just a question in the middle of the room. Yeah.
Yes. Thank you. Look, my question, I'm Ruth from M&D Association of Victoria. My question to the panel is, with footballers being at seemingly increased risk of M&D, what's the panel's thinking on concussion and brain injury and the link with M&D?
So people have looked at whether traumatic brain injury increases your risk of MND. In fact, a study has just recently come out suggesting that it might, and actually also might increase your risk of other neurodegenerative disorders. But if you look pathologically under the microscope, people with traumatic brain injury that's chronic can develop the same types of pathological change. They can develop TDP-43 accumulations in the same way as people with motor neuron disease can. So that might be a mechanism, but it's not necessarily people who head the ball who get it. And people who box, for example, who are getting repeated head injuries are actually at more at risk of Parkinson's disease rather than motor neuron disease. So it may not be that head injury is relevant. It might simply be that being athletic is relevant. And as I said before, just because it's associated doesn't mean it's causal. It might just be that if you've got an athletically tuned body through evolution, that's what's predisposing you to get motor neuron disease.
Yeah, well, I think the study that Emma was talking about was in the New England Journal of Medicine about a month ago, showing a significant increase in motor neuron disease linked to CTE. I think this is it's a controversial area that does need a lot more research. So I think the jury is still out. The other thing is we're talking about chronic trauma causing TDP-43, so the pathological signature. We still don't fully know that TDP-43 is causative. So is that an effect or is it causation? So a bit like, a fire going through a forest, the fire sort of passed and then you're left with the charred remains, and that's the sort of TDP-43. Was it the TDP-43 spreading that caused the process? And I think more and more I would say it's probably an effect, but it's a marker.
Any other comments on that one?
No.
Jeff?
Yeah, just wondering, we spoke of it before, but is there any link with the way our food is being produced and chemically, we're not picking it from the trees when it's ready, where it's growing in a fridge and it's, all those genetic changes to our foods compared to the caveman that used to go out and hunt and get it real.
So I don't think there's been a study of processed food versus unprocessed. Leonard might have done it in Euromotor. No. So I don't think you can fully answer that with the available evidence. Processed food versus unprocessed, we don't know.
Yeah. Facebook question?
It's a big question. It's from Ross. How many years do you think it will be before we have a cure?
It could be next week or it could be another 10 years. We don't know. Sorry.
I think it depends on what you mean by a cure for everybody or a cure just for a proportion of people. Because I think the 2% of people who have SOD1 mutation, antisense therapy is around the corner and we may have a cure in a year or less. If you're talking about a cure for everybody, that's a very different thing.
Yeah, well, I think the genetic conditions are going to be cured a lot quicker. And I think that it wouldn't be unreasonable to think that within the next 5 to 7 years, there'd be more effective therapies generally available.
Yep. Any questions in the room before I read out another one from online? So this is a wordy question about collaboration, really. So we've sort of discussed it a little bit through your talks. It says, this event shows the need for and the power of international collaboration amongst academics. Big Pharma is, of course, global also. Given the commercial needs of the major pharmaceutical conglomerates, question 1, would it be possible to put them together into a global academic and research strategy that might persuade and enable them to accelerate development once prime targets are identified? And 2, what might that strategy look like? So I think some of you addressed that in your talks, but...
These kind of meetings are very important. So we talk to each other all the time. It's the busiest week of the year. It is extremely important to collaborate. We do collaborate a lot, and so I think if anyone worries that we don't collaborate, that's actually not true. But sometimes there's also some competition, which is also good, because that makes us work a little bit harder, and even our PhD students work harder. So some competition is not wrong, and sometimes you need replication. You need to have the same study, two centers in the world, confirming each other. That's actually very important in research. So you don't need to do everything together, but for some areas like genetics, also biomarker studies, trials, you can't do it on your own. You can't do it just in one country. You probably can't even do it in one continent. You need to collaborate to get good results, and we do, and we need to encourage that. And we also need to encourage that the foundations collaborate with each other, because then that helps us to collaborate as well. If the funding is, but on the other hand, we don't need one funding thing for the whole world. I think, I don't know if you want to add to that.
Yeah. So I would completely agree with that. We already collaborate very strongly together, and that is essential, because without collaboration you don't get the numbers. I think there are 2 types of researcher. There are the types of researcher who like to keep everything themselves, and the type of researcher who doesn't mind sharing the information. And if you're part of the general public, you might say, well, why doesn't everybody just share their information? The reason is we're measured by our universities by the number of publications we make and where we are in terms of the publication position. And we're measured by the grant-giving bodies that give us the funding to do our research by our track record, which is the same thing. And so if you share your data, you're effectively diluting your prominence in the field potentially. And I think what we have learned, definitely the 3 of us on this panel and others, is that by collaboration you actually boost your output, because you get a more powerful result because you've shared your data with other people. And not everybody has fully understood that, but I think that's a general trend across the world, and in research, and in motor neuron disease particularly. We're actually a very collaborative community of researchers, and we do work very strongly also, of course, with patients and patient foundations, and actually also we're beginning to bring pharma on board. There's always been a reluctance because pharma is commercial and we're the opposite of commercial. And there's always been a kind of conflict ethically and culturally and all of those kind of things. But we are beginning to bring pharma on board much more and work globally with them.
And I think one of the key drivers has been this international symposia. So meeting up over the many years, coming to meetings and hearing each other present results and how to go about it, that's been a learning experience, but it also then drives friendships. Friendships to the extent that Leonard sends his daughter to come and stay with me for about 3 to 4 months on a 1-weekend visit to Sydney. But
turned out that Matthew is a better father than me, so I hear that every week. But he does barbecue on Friday night, my daughter says. I never do. I hate barbecue.
Yeah, I think the consortia and the meetings are fantastic. I think we've always wanted international pharma involved too, but it's been an area that they didn't want to invest too much in. But and that's why I think the community awareness, the Ice Bucket Challenge, and the philanthropy that is there to bring trials to Australia, to get Australians to collaborate with Europeans and North Americans. And then we can also see the power of improving the standard of care for patients across clinics to say, well, this is the model of care that ideally we'd like. But you have to have some sort of vision of where that is. And that only comes through the interactions at national or local, national, international meetings. So I think this symposium is a critical part. And the things that are going to happen both are sort of covertly and clearly, and in breakfast meetings and dinner meetings, and all of these events are critically important to basically accelerating the path to treatment.
Yeah. Can I just add one more thing, which is that the other sea change that has occurred in our collaborations is the involvement of patients in actually the design of the research, and in which questions need to be answered and how we answer them, and how should we do a trial, how should we do the research, is it acceptable the way we've designed it? That's a new thing that's happened in the last few years, and it's increasing.
Yep. It's important that we measure what you guys think is important. There's no point us measuring a change in strength if that's not what's important to all of you. I think we'll just take one final question from up the back, if that's all right, because we're just getting close to closing.
So I just locked in. Blue-green algae's been in the media in recent years as a potential cause for MND. Do you know if there's any research going on regarding that topic, and what's your personal views towards it?
So blue-green algae are supposed to produce a toxin, a cyanide-related toxin. So there's a kind of theoretical reason why they might be important. There is, if you look in the literature, there are a few examples of outbreaks of motor neuron disease-like conditions that have occurred when people have consumed mussels that have been where there's been an algal bloom. So it's not impossible that they might be relevant, but those kinds of examples are motor neuron diseases that are static, a bit like polio. So once you've got it, it doesn't then progress in the same way as normal motor neuron disease. I'm not aware, if you look at those location map type studies like the one I showed you, there's none that necessarily accumulate around the coast or in places where people eat more blue-green algae, things that have eaten blue-green algae.
Terrific. Well, I'm just going to make a few closing remarks and thanks. I hope that you all really appreciate what a fantastic session this has been for all of us. I first of all want to thank the International Alliance of the MND and ALS Associations for hosting and sponsoring this session. To the volunteers and the organisers from Motor Neuron Disease Association of Australia, and in particular I want to recognise Carol Burks and all the amazing work that she's done to pull this together, as well as Morag and Ben here who have been fielding the Facebook questions. Thank you very much. And from the volunteers from MNDWA who have been running around all afternoon in all the sessions, but here with the microphones, that was fantastic. I want to acknowledge the courage shown by Mr. Drew Bathgate to come up here on stage and open with his story. I think it really set the tone for a fantastic session this afternoon. Then we opened with Professor Matthew Kiernan, who emphasised again the importance of collaboration. And if you haven't picked that up this afternoon, then you need your hearing checked. Matthew emphasised the importance of collaboration not only for research but to improve our understanding of the disease, but also to improve the treatment of the disease and really to standardise it across not just Australia but the world. And he talked about the new trials that are around, and I think provided really some really serious hope for the future for all of us here. Professor Al-Chalabi discussed the mysteries of motor neuron disease, and in particular talked about the 6 steps to developing motor neuron disease, and the genetic factors really account for 3 of those steps, but then there is another 3 steps or another 3 hits that we don't fully yet understand and probably going to be different for all sorts of people. And then we finished with Professor Vandenberg from the Netherlands, who helped us understand the phases and the processes of clinical trials and some of the difficulties we face when designing clinical trials. He talked about the back to the future model, which would be the best model for clinical trials if we could really do that without having to put people through the placebo arm. But until then, the importance of having that placebo-controlled arm. That's often a question I'm asked when I'm randomising patients for clinical trials. But I think it's really important to understand that if you're in the placebo arm, it's just standard care. It's not that you're getting nothing, you're still getting standard care. But you may or may not get the active drug. But hopefully you will get it at the end of the trial if it's positive. And really we need to aim to involve as many patients as possible in clinical trials, and we would ultimately aim to offer clinical trials to all patients as they come into the MND clinics. So I think that's been a fantastic session. You've asked some wonderful questions. I think the panellists are probably all in need of a drink, I think, to recover. And I would invite you all to stay and mingle and network over afternoon tea. So thank you once again for your attention and your participation in this session.